One of the fundamental problems with NFPA 780 is that it treats structures that contain flammable vapor in the same way that it treats structures that don't contain flammable vapor, which is not a good idea. And rather than provide any protection, it can increase the risk of damage. Consider a lightning protection system as would be recommended by NFPA 780 for a structure like this house. Assuming the system works as intended and safely conducts the lightning current to ground, an enormous potential is applied to the lightning protection system. Using a numerical example from NFPA 780, which only considers the resistive component, gives us an applied potential of 2 million volts. If you apply 2 million volts to metallic objects like slender conductors, pipes, or other objects that have edges and corners, they will produce corona discharge, or sparking. Actually, most of these objects, by virtue of their geometry, would have corona onset potentials in the range of about 100,000 volts, so 2 million volts is 20 times more than needed to produce sparking. So, as it's doing its job and safely conducting the lightning current to ground, all or portions of the lightning protection system can produce momentary bursts of sparking. Of course, these momentary bursts are not a threat to structures like a house. The energy released is insufficient to ignite materials like wood or to damage concrete or bricks. However, if you use this same concept to protect a fiberglass tank that contains flammable vapor, and you electrically connect the tank's metallic components to the lightning protection system, as would be recommended by NFPA 780, just like any metallic objects that are connected to any such lightning protection system, in the event of a direct strike, they can produce momentary bursts of sparking. Except now, that sparking is inside a non-conducting tank that contains flammable vapor, and the energy released is sufficient to ignite those vapors. Making matters worse, NFPA 780 further recommends putting long conductors inside the tank, which include sharp points, conducting tinsel, or similar. A concept which is not supported by any peer-reviewed publications, laboratory, or field testing. Whereas most of the conducting objects in the tank have a corona onset potential in the 100,000 volt range, for these devices it can be as low as 2,000 volts, making them highly prone to hazardous sparking, both due to direct strikes to the protection system or due to the effects of nearby strikes. If the objective was to intentionally set one of these tanks on fire, strictly using the energy from a lightning strike, it's hard to think of anything better than installing an NFPA 780 compliant lightning protection system. If you can think of a better way, please let us know in the comments section. The only way to protect a non-conducting tank that contains flammable vapor is to provide it with means of electromagnetic shielding, like the EM shield by Lightning Electro-Technologies. By forming an appropriately designed conducting enclosure around the tank, this ensures that any sparking due to direct or indirect strikes only occurs on the outside of the tank.